Okay, so we're now gonna have a look at part two of this introductory training session on how we use Git to do software versioning, software configuration management, and I tend to use GitHub. So how we use GitHub with Git, although you don't have to use GitHub, you can use all manner of different tools, as I mentioned in the last talk. Now, in part one, we went through a couple of bits and bobs, really, why we do versioning, how Git is put together, installing it and getting a repository going, cloning that repository locally, making changes, staging changes, and committing them, and then having a look at how we do commit messages and dealing with issues. Then we set up some credentials, some SSH public private key credentials to be able to push our changes into our repository on GitHub. And we looked at doing that, at pushing up the main branch, which you may remember we were working on. And that's where we finished. So we're going to move on a little bit into, I mean, that was sort of really the very basic 101 stuff. And we're going to move on a little bit into some next steps, which hopefully we're going to try and cover some bits and bobs. Git ignore, how that works, branching and merging, working on branches, cherry picking commits, resolving the conflicts when we try to merge our changes, and we may get on to diffing and patching. We'll basically see how far it gets. And as ever, although I'm probably going to end up doing a lot of the talking, this is really more intended to be a conversation to help with any questions that arise. So I'm Shreya and Yahya here. If you have any questions, please do feel free to jump in or indeed corrections, because I did get a couple of minor things wrong in the last talk, which the eagle-eyed viewer may wish to reply about. So here we go then. Now this is building on the last set of setup that we did. So I've got this Git user on the computer here. You can see that ID is Git user. We set up credentials for that user. I've got a Git test repository that we created. A slurp of coffee. Now, I think what we're going to do is we're going to start off with a really skeletal kind of set of changes to try to make some things clear. And then possibly we'll go and have a look at one of the other repositories that I maintain to illustrate some of these ideas. Now, I have, in typical Blue Peter fashion, done a tiny, tiny little bit of C code, which we can look at here in main.c, which simply prints hello Git world. And isn't that fantastic? It's very, very, very noddy. So I've also just created a little build script, and all that does is compile the source code main.c to an executable hello world. And we're going to do that in a bit, and we're going to run it. Now, I've, of course, made those changes. So I haven't done anything more than that. I haven't staged anything, committed anything, done any Git magic. So let's have a look at how I would then deal with adding my changes into this Git repository. Well, firstly, I like to know where I stand. So I would tend to do a Git status. And you can see there's some untracked files because I've just added them in red. Red, tends to be things that we need to have a look at. And that's much as I expect. If I want to have a sort of quick check of my changes, so if I want to have a quick check of my changes, I'm going to stage them first. So what I'm going to do is I'm going to add, I could do build.h and main.c, but if I just do add, it'll add everything in the local space that needs adding to be staged. So if I now do git status, you can see there's some new files to be added, to be committed. And if I do a git diff, still doesn't work. Okay, I'm not sure why that is. Let's leave that and move on. If I commit my two new files into the repository, and I'm going to put a message in there, and I'm going to say, okay, add a very simple C source file and build script. And I don't really need to say anything more than that. As we said before, just you need something that's indicative of what you're actually doing with your commit. You only really go into more detail if it's necessary. So I'm going to save that. That now has been committed in. If we look at the Git log, you can see I've got my new commit. Now I now should be able to do a Git diff. It was probably because there were no files before that there was no difference. But if I do a Git diff there, yeah, I can see that what's coming out is a diff. It says it's a new file. And that's a build.sh file. It's got that line in, which is GCC line. There's another file, main.c. That's also a new file. And that also has some lines in, which is the code in terms of what it actually does. Great. So that's, again, that's been committed into the local repository, not anywhere else, not any remote repository. So if I now go to our Git test repository that we set up on GitHub, remember we set up the remote here. What I'm going to do is I find it a bit messy here with what we're doing with this origin and this SSH, because they're basically, as we said, the same thing, but with a different protocol so that we can actually authenticate. And what I think I'm going to do is I can never remember how to do it. So I'm going to look it up and I'm going to do change remote URL. And how do you change the URL for Git repository? Git remote set URL. There we go. That's what we want. So what I'm doing here is I'm going to say git remote set the URL for origin, which is currently set to that HTTPS URL, to a different URL, which is the one that we're using for SSH to authenticate. So if I do that, set that URL, seems to have worked. Let's have a look at what the remotes are. And you can see now I have set that origin. And so because I've done that, I don't need the SSH one. So what I'm going to do is try and remove that SSH one, which is remove git remote, remove SSH. And if I now look at my remote, that's nice and tidy. So I'm not going to get confused about what I'm doing with that. Again, everything else has stayed the same. Git log, I had a very simple C source file. And what I'm going to do is now push my to the origin, which changed, my current branch, which is main, and that should hopefully go up to the GitHub repository. We can check that. We can go over here, see there's the license and the README file, and ta-da, look at that. We've now got the extra files. And if I go and have a look at main.c, click on that, you can see the colorized files. Quite nice and really cool stuff going on in GitHub. And you can have a look at what's going on. Now, one of the things that we do within the team that's really, really, really helpful, I find, is, we're looking at a bit of code and we're trying to figure out, what needs changing and what problems there might be. And maybe there's a problem on this line that I've been working on here. And I can hover over that number. You see it just lights up, doesn't it? I can click on it and I can copy what's called a permalink. And I can then give that permalink to somebody else in the team, and it will go straight to the bit of code that I'm looking at. We can have a bit of a chat about what we might need to be doing with it. And I find that to be very, very, very productive. You can do other things as well. You can have a look at that and do that yourself. So next thing, we have committed in our really basic source file on our build script. We might want to document things, but as far as I'm concerned, the next thing I want to do is to start sort of making some changes. But before we do that, as Shreya reminded me just before, gitignore is quite a useful file to keep tabs on. It's a dot prefix file again, so you have to do a -LA to see it. And in our gitignore file here, if you remember, we populated it with a default set of settings, which are relevant to people who do C building of things. Now, I don't really want to go through how you build C language artifacts, but you get .o files for objects and .lib file for libraries. And you see These are all wild-carded. And basically what this is saying is that anything that ends with a .o or any of these other endings is going to be ignored. And that's because usually when we're archiving our source code and related files, we don't want to archive all of the output, the binaries, particularly the intermediate stuff. Yeah, you can take different approaches, but it makes everything very, very messy, and you start to be shown all sorts of binary changes that you don't care about. And generally what you want to be able to do is take a known set of source code to build your output artifacts. So you're not worried about actually the output binaries. And so what you do is you ignore all that stuff. And that makes sure that when you try and do git commits and so on and so forth, it's not going to pull in all those files. Now, there can be an argument to archive release artifacts and builds. And particularly, if you're programming images onto devices and you need to have kind of golden images of what you're going to program and version that so you can always go back to previous images, you do want to be doing that kind of thing. But arguably, you would archive the build and particularly the output artifacts somewhere else, maybe a different repository or in some other way. You wouldn't really tend to do that in your source Git repository, again, because it makes it really hard to go into it and actually see what's going on. You're trying to look at differences in bits of source code generally. That said, often you'll end up having configuration files that go into your Git repository and sort of files that drive how a build might work. And that's all very, very relevant. They will also almost always, I would imagine, tend to be a human readable, some kind of text form, whether that might be plain text or CSV, JSON, XML, who knows. It is possible to store files in the Git repository. It's just a file. There is a limit on file size. I can't remember what it is, but if you get up to big files, say you were trying to store videos and things for some reason, maybe you're putting videos into a repository because you're going to build a website out of that repository, maybe. And there's a Git LFS plugin for large files, which you can look at. And if you get odd errors with files that are actually quite large, not really being there, and you have instead very short files, that's because you've not got your Git LFS switched on. But that's sort of outside the scope of what we care about here. So that's a set of default things that Git will ignore for this repository. And what I'm going to do is I'm going to try and do a git status again, and that's clean because we added those two files that I added, didn't we? Now, typically I might be working, so I'm doing my work, I'm building, my project, I'm doing my stuff. And if I run my build script, which you'll remember just runs GCC on the .c file, the source code, and I look at what that did, that has generated an output file, a hello world file. And you can see that. So if we look at the build script, it says GCC output hello world file built out of main.c. And if I run that file, hey presto, you can see that it just says hello world. Great. Now, so we now, as I've gone through my build process, we've got this new file. And if I do a git status, it says it's an untracked file. Now that's a binary, isn't it? So I don't really want to archive that. That's messy. And if I had a bunch of changes and a bunch of files and I just did git add dot, as I did before, to add everything, it would add all those kinds of files. So you can imagine we've got a few of them, particularly lots of intermediate files. It all gets really messy. So I don't want to do that. So what I'm going to do is I'm going to tell Git to ignore the hello world file. And I'm going to do that by just adding it to the bottom of the .git ignore file. I can't remember if I have to commit it, so let's have a look. Aha. So look at what happened here. The git ignore is telling Git to ignore the hello world file, and therefore that now has disappeared. That is not an untracked file. Git just doesn't care about it. It's gone, whoosh. Although it's still there, but Git doesn't care about it. But it does say, because the git ignore file is archived, that that file has changed, which of course it has. And if I look at how that file has changed, you can see that there's one an empty new line and one new line, which is my hello world. And so you can see that as well as archiving my files as I do development, I want to archive the configuration of the repository, the setup of the repository. In terms of this, it's the gitignore. So I'm going to add the gitignore. That's now staged to be committed. And I'm going to commit that. And I'm going to say, ignore the output hello world binary. And I'm going to push that up. As you can see, that's now updated. And we've got that new hello world line there. And if I look at the commits, 4 commits now, and it shows me that I did a message saying, ignore the output hello world binary. Okay, that makes sense. And it shows me what I changed. So hopefully that's pretty straightforward. So that's how gitignore works. One other thing that's worth mentioning, when you get into more complex tool chains, you're looking at build systems like CMake and Make and Ninja, and there's quite a variety of these things nowadays. And often what they'll do is put all of your build output into a particular directory, which might be a build directory, say. That's quite often the case. And I've just created that directory, so it's there. But if you look at Git status, it's not saying anything, which is kind of odd, and you can get a bit confused about this. But if Git is telling you that something isn't to be tracked, and you know it's there, maybe you think it should be tracked, the thing to do is have a look in the gitignore, and what we'll probably find is in the gitignore, there isn't a build folder. Well, I don't know why that is in that case. Maybe if I go into the build, touch a file. Okay. So the reason that wasn't there before was because it was an empty folder. So it was ignoring an empty folder. It's now an untracked folder, and anything in that folder is untracked. And if I was using a more complicated build tool chain, then I would probably just want to say, look, everything in this folder I want to ignore. So I'm just going to put build at the end of build slash to indicate it's a folder. And if I do that, whoosh, that folder's gone now. So it's not just a file thing. You can also remove entire hierarchies of files within folders just by specifying folder names. And you can also wildcard those folder names. So I'm going to add the gitignore now, and I'm going to say that I want to ignore the build folder and push that up. Again, that's changed. It should be 5 commits, I think, now, and there are, and the hash of the latest commit is new, and off we go. So I think that's probably all we really need to worry about with gitignore. And the next thing is that it's probably worth having a chat about branches. We've got branches and forks and tags and all sorts of different things that are kind of related. And it's all to do with trying to make life easier for developers who are working. Now, we said that we started out with this default main branch. Oops. See, talking and typing. Default main branch. And I could, if it's just me, I could be making my changes, doing my development, committing things as I go, and just do all that on this branch. Why not? That's fine. But as soon as we get a couple of people who are working in parallel, it can get really difficult to keep tabs on, if I'm pushing things up to a main branch and somebody else is, it gets difficult to manage. And so what tends to happen is I will sort of take a copy of wherever the main branch is now, and I'll create a new branch from that. And so we can sort of think about this like a tree, yeah? So we start off with the kind of the trunk of the tree, which is our main branch growing up. And then we branch off and branch off and branch off and branch off. And we can take branches off branches off branches off branches to do all sorts of different things. And then the kind of the main branch is still there. And then what we might do is do our work on a side branch. And then when we're happy with what we're doing with our work, and that's sort of out of the way, that's not bothering anybody else. That's on our own branch, you know. And when we've done whatever we were doing and we want to kind of bring that back into the main branch, which is like, say, maybe the product release, we'll merge our changes back in. We'll go through a process of doing that. And that keeps things quite controllable. And it means that people can work independently on their own stuff without other people making changes underneath them and confusing the heck out of everybody. And one, so the specifics of how a team will manage this development process tends to be very much up to the, whoever's running the team, and different people have their own preferences. And I'm not here to advocate one thing over another thing. I have a particular way of working, but I wouldn't say it's any better or worse than any other way of working. Whatever makes development simple and understandable and straightforward and clean, to me, is a good thing. And also, whatever makes your development sort of auditable in the future, so people can come along and go back through what you did, because that's often very useful. So say somebody comes along to me and they say, right, well, we've got this super amazing program that prints hello world. But the client wants a new feature. The client wants us to print the first couple of digits of pi because they're really interested in us doing that. So, my job now is to go away and add that stuff in, add that feature in, say. And so what I might do is I might work on a feature branch to add the feature. And I'm going to name that something. Doesn't matter what it is, could be anything, but naming conventions are helpful so that people can understand what other people are doing. So I tend to create my feature branches with my initials and a slash, and then something to do with whatever I'm doing. We don't want it to be too long. So to create a branch, firstly, we look at where we are. We're on main. And where we are on main is at this commit, 79A commit. And so what I'm going to do is I'm going to create a branch from this point so I can go off and do some different things. So to do that, we do git checkout -b for branch, and then the name of the branch, which is, in terms of how I do things, AJL add pi digits. And it says it switched to a new branch. Great. And if I look at git branch, it shows me in green that I'm on this new AJL add pi digits branch. And there's another branch it knows about, main. This all gets a bit fuzzy for me because you can have branches in remotes, so on GitHub, which I don't have locally. And this sort of goes back to what I said at the very beginning, that you have this sort of local like database of all the Git data on what's going on, but you actually don't always have everything, because you might not need every branch because you're probably only interested in a couple of branches that you're working on and whatever you're going to try and merge back into, or you might be testing. So it doesn't always pull everything down unless you ask it to, which you can do. So we're on this branch, and then what I'm going to do is I'm going to edit my file, and I'm going to say, let's add in a line, printf pi, and then I'm going to put in 3.0415, and hopefully that will work. In fact, let's make an error. So that isn't going to work, I don't think. So what I'm going to do is I'm doing my development. I'm going to run my build script. Oh, got a problem. It's telling me there's a missing semicolon, which those of us C developers know we have to at the end of lines. Put that in, build it. Wait, that worked. So I've done my development now. Speedier than most development we normally undertake, but there you go. Done my development. I'll do a bit of local testing. I'd like to see if my stuff works. So do my testing. Oh my golly, it's printed pi. It's added in a couple of zeros at the end, which are obviously incorrect, but I don't care. I'm going to leave that for somebody else to worry about fixing. So now I've got my branch and I've done my work and I've done some testing and I'm quite happy with that more or less. Maybe actually what I want to be doing is a peer review. And they may pick up on the fact that I haven't spotted that those two zeros are wrong. So peer review is a good thing. But as far as I'm concerned, I'm okay with this. I think that's all right. So I'm going to do a git status, and it says you've changed the main.c. And say, well, what have I changed? What have I added in that line? Okay, fine, cool. Well, I'm done. So what I'm going to do is I'm going to commit that, and I'm going to, oops, sorry, I've got to add it to stage it, and then I'm going to commit it, add some digits of pi. Save that. Have a look at the log. See that? New entry, new unique hash, add some digits of pi. Now, but look at the top. You can see that I'm on the head of a different branch now. I'm on the head of AJL add pi digits. And if you look at the commit before that, that was on the main branch because that's what we did. We took a branch off the main branch. So that's kind of how we're working now. So I'm making all my changes, but I've gone off over here. And on the main branch, nothing's changed. And hopefully that's coming across. So I'm quite happy with that. That's pretty neat. What I'm going to do is I've got another job to do now, So what am I going to do? I'll tell you what, I'm going to leave that branch where it is, and I'm going to go back to the main branch. And so to do that, I do git checkout main, and I don't have the -b because that branch is already there. I'm not creating a new branch. And that switches back to the main branch. And now if I look at the log on the main branch, that doesn't have that new commit that I made with my digits of pi because that's over on my new branch, you see? So the main branch is now sort of behind things a little bit. And what I want to do is I now want to, I don't know, the guy comes along again, the boss or the lady boss, actually, maybe. She comes along and she says, okay, I got another job for you. The client wants some other stuff going along. And he wants you to maybe ensure that you exit with an error. And that's how we exit with an error in C, or it's one of the ways we can do things. So I'm going to exit with an error. Now, actually, I've made a little bit of a mistake. So I'm just going to save that like so. And what I'm going to do is I'm going to check what branch I'm on the main branch. And I'm going to check on the status. And this is, well, I've changed some stuff. I don't want to commit that into the main branch because that's a bit naughty. What I want to do is what I did last time. I'm going to make another feature branch. So I'm going to git checkout a branch AJL exit with error, and it switched. And then again, everything is the same. It's got my change here. But look at what I've changed. Those are the things I've changed. I'm going to do a quick build, see if that worked. Oh, I got that wrong. Okay, exits undeclared. That's really cool. And it never used to do that stuff for me. It's telling me what I've got missing. Wow, this is like proper development, isn't it? Fantastic. So if I'm going to include stdlib, okay. And I think I'm probably programming in JavaScript or something here. So let me try and see if that works. Yeah, that worked. That's okay. And if I run hello world now, it doesn't actually tell you when stuff errors with an error value, but I think we can do this. The dollar, I mean, we're tangenting here, but the dollar question mark in the bash shell gives you the last returned exit code of the process that you ran. And it's telling me it's 255 because 255 is the unsigned byte version of -1. And just in case you don't believe me, let's change that and make this a +1 and rebuild it and rerun it and check the return code, which has now gone to 1. Would I lie to you? Okay, so I've done my work. I've added in that sort of exit code thingamajig. I don't think I've committed it, have I? So let's stage that and commit it. And let's say added an error return value of 1 to main function. And then we're gonna push that up. Oh, interesting. Okay, let me tell you what just happened there. You can sort of specify more or less things when you're using Git commands. And typically, the full command for what I'm trying to do here would be to git push origin and then the particular branch that I want to push up. So origin AGL exit with error. Maybe I don't want to do that all the time. So it's helpfully saying to me that it's possible to set a default on this branch so that if I do a git push, then it will know what I mean is I want to push the AJL exit with error branch to the upstream origin. That makes my life easier. So let's set that. And that's now set. And that's now happened. And if I did a git push again, nothing has changed. So it will tell me nothing has changed, but it knows it wants to be pushing up this current branch that I'm on. And just to show you that this is branch specific, if I check out the AJL and the pi digits that we just did the work on before, and I did a git push, that is not set because I didn't do that. I set it on the other branch. So what I'm going to do is set up this branch to automatically push itself when I say to, and everything just gets a little bit easier. So that's interesting. So now whereabouts are we? We've now got two feature branches for the things I was asked to do. And we pushed those new branches up to the GitHub repository. So we should be able to see them. If we have a look over here, oh my word, how clever. It's telling me that it's just had some new pushes going on. Pretty neat, eh? And there you go. We've got two different branches with pushes, and it's asking me if I want to do some stuff. We'll have a little talk about that in a sec. Now, what I can also do is I can look at my, pull down that sort of main branch there, and it's showing me the two new branches. And it will tell me if I go on to the other branch that this branch, AGL pi digits, is one commit ahead of main, because that's what I did. I branched off main and I did one commit. So I'm one commit ahead of main, and it shows me that that's the change I made on my branch. And if I had made more changes, it would show me more changes. And then the other one I could do, have a look at what I did in the other branch, exit with error. Similarly, I'm one commit ahead of main, and it's a little bit more messy here, isn't it? Because I made a few different changes. Now, quite a lot of the stuff that you can do on the command line, you can do with the GitHub portal, or you can do it within your integrated development environment. Probably easier to do it with the GitHub portal, but I'd like to show you how the command line works because it's useful to know how the command line works. So what I might do in the command line is if my developers sort of been doing some stuff and we're doing some peer reviewing, and we might do that peer reviewing via GitHub because it's a pretty good way of looking at things, you can see. And then we've done that, we're happy with that. And what we actually want to do is merge those feature branches back into the main branch. So what I'm going to do is I'm going to check out the main branch. Again, I'm not creating a new branch. If I look at the log, you can see that I'm back to where I was before. And what I think I want to do first is I want to merge in that feature branch where we were doing the adding of the pi digits. So what I'm going to do is git merge AJL add pi digits. Wow. And it's worked. So it says it's updating and it's changed the main.c file, and one file has changed. Happy. Now that worked because there's a certain amount of smarts in it working out where a change has happened and how to merge those changes in. It can get confused when things get complicated. For example, when two different people have made changes in the same place, And then it will say, I don't know what to do here. You're going to have to get involved. There is a conflict and you will have to manually resolve it. And there are different kinds of merging strategies that we won't worry about at the minute. But having merged in that feature branch, I can now look at the log, and you can see that on my main branch, we now have the commit from the feature branch. Isn't that great? So what I could do is then delete the feature branch to get rid of it, to keep things tidy. I'm going to leave that there for the time being because who knows, we might need to go back to it. And what I can do is I can then push that up to the GitHub repository if I so wish. I'm not going to worry about that for the moment. We don't always have to do that. So I've merged in that feature branch. Now what I think I'm going to do is merge in the other feature branch. So let's merge in AJL exit with error. Oh, got a problem because I've got the main branch and I made some changes with my pi digits and I pulled them in. But I also had this other branch off the main branch, and I've tried to make changes in the same place. If you think back, where I'm printing those digits of pi on the other branch, I'm doing an exit. So this tooling knows there's some kind of problem. It's not AI, it doesn't understand the intent behind what I'm doing. It just knows that I've made two different changes in the same place. And it's saying, I don't know what you wanted to, I don't know your intent. I don't know what you wanted to do. So I'm going to need you to fix that for me, please. And there are various different configuration options about how you can fix that and what tools you can use to fix that. But in the very simplest of cases, what it has done is, it says here, it's tried to auto merge main.c. There's a conflict, merge conflict in that file. It's failed, and it's asking me to fix the problem and then commit the fix that I require. And what it's done is it's edited the content of that file where there's a problem to show me there's a problem. So let's have a look at that. If I edit the file, you can see it's added in a bit. It said that in the head version, which is the current branch I'm trying to merge into, which is main, there's a line here that says print the pi digits. And that's right, because that's what we added. And then it's saying here, there's this other line, which is coming off the branch we're trying to merge in. So these left arrows is what you started with, and these right arrows are this new stuff, and it's asking me to make changes. And I might want to get rid of the pi digits or the exit one, or in this case, I actually want both. So I'm just going to delete that head and delete those equals and delete that last line, because that's what I want. I want my exit. Now you see, it didn't have a problem merging in the new stdlib line. Remember, that was new off the branch as well. But that wasn't an issue. It just added in that line, and it hasn't said anything about that because that just worked. And it only flags this stuff up when it just can't work out what to do. Hopefully you can sort of see why there's a conflict there, because it doesn't know the right thing to do. So I've fixed that. Now, that's how I want things to be. That's my merging exercise going on. You can well see that if a developer's working on a branch for a while, doing something quite complicated, and maybe the main branch has kind of gone on and other things have happened, it can become quite a job to do a lot of merging if there's a lot of conflicts. And that's something that needs to be managed well, perhaps by getting different developers to work in different pieces of code, or to have some kind of strategy, or often one approach is for people to say, well, we're going to merge things in quite regularly. We're going to make small changes, because it's much, much easier to do this kind of review with small changes of a few lines than massive blocks of code. You might add in a whole new file, as a massive block of code. But if you're making changes to things, if you give those changes to somebody to review, they will be much happier if you give them a lot of little changes that are easy to see what's going on instead of like a huge big block of complexity, which is overwhelming. So as with open source strategy, release early, release often, this is sort of, small changes, commit often, review often. Everybody will have their own view on best approaches for these kinds of things. So I'm going to save my file, and I've fixed my conflicts. If I now look at my status, it's saying that the main has been modified sort of from both ends. And I'm going to add that file because I'm saying I'm happy with that now. I've sorted that out. And I'm going to commit it. And there's an existing message because that's what we started trying to do. We tried to merge in the AJL exit with error branch. It told me there was a problem. I fixed the problem. I told it to use the file that I'd fixed. And we're finishing off this operation of merging now. I can change that message if I want to. I could say, had to sort out an issue with new pi digits and exit call on same line. Something else to mention at this point maybe is perhaps it's not as relevant nowadays, but there has always been a limit on the length of the messaging lines that people tend to use. A lot of older systems will truncate the messages that you use if you go too long. There's a couple of different standards, actually. I can't remember what it is. I think it's maybe 76 characters or something like that. Some of the IDEs that you use will have a little line on the right-hand side, which will show you when you're going over. And what you might want to do is to make sure that you keep your initial message on your sort of, your single line within that limit so it doesn't get truncated, which is very irritating for anybody trying to pass through log entries. And then you sort of put the rest of things in your description below, and ideally you don't get the description too long. It feels like my description line is a little bit too long there, but again, we're not too worried. Just something to bear in mind. So save that. That's now gone. You see that merge has gone in. We're on the main branch. We've merged both of these things in. We're now going to push that branch up. And if I go back to my Git test repository, go back onto the main branch, I've now got all of those commits and I've merged in the feature branches. And that, in a really kind of, stripped down kind of way, is how we do feature branch, development on feature branches. So everybody they take their own branch, they do their thing, do local development, test out they're happy with it, do a peer review probably, and it gets pulled in and off we go. Yeah. Now let's do that again, but let's make use of some of the kind of the extra tooling that GitHub gives us. And this is sort of more specific to GitHub than Git, so it just builds on top of Git. And other providers like GitLab and Atlassian, they will do the same thing in different ways. One of the things we've got here is that you can see that on the command line, you can, of course, do anything you want. And I think it's very useful to have an awareness of what the command line arguments are for certainly the usual operations. I can't remember them all.
Sorry, Alex, I have a question for you.
By the way.
Yeah. So if someone clone branch from the main branch and then I again clone some like new branch from that older clone branch and then someone deleted the first clone branch, what happens then?
Can you say that again? I didn't quite follow that. So if you clone.
If I clone one branch,
Yep.
and then I clone second branch from the first branch, and then if I delete the first branch, then what happens with the second branch?
Okay. Yeah, that's interesting. I don't actually know the answer to that. I think that the your second branch is still valid. It still works. It's still there because I think the second branch includes all the information that you need that was taken from the first branch. I don't think that deleting the first branch would break the second branch. You just wouldn't have the first branch information.
Okay.
Yeah. But it's a really good question. Why don't you try it? Try it after this and come back and tell us what you find, because that would be quite interesting. Git's like really very much designed so you can't break stuff by doing things like that. So it would be a huge surprise if you could, but I don't think you can. But again, as before, a lot of these things, I mean, this is separate from your question, but a lot of these things are judgment calls. And, do I delete a branch or not? Well, if you don't delete branches, you end up with like loads of like these little branches all over the place. It's very messy. It's very hard to see what's going on. If you do delete branches, you might want to go back to something and it's harder to sort of find and figure out where things are. So again, you just have to sort of make a bit of a call. Yeah. So, but you have also raised another couple of things. So I might continue and I'll mention that before we go on to that, we're sort of running low on time for this session, aren't we? So we need to wrap up soon. But if so branches, we talked about feature branches. Quite the branches, as is probably obvious, you can use a branch for all sorts of different reasons. Might not be to do with development per se. It might be because you've got different releases of things. Like you've got lots of different releases of Android. If I've got some code, maybe my core code doesn't work with every release of Android. So maybe I've got a branch of my code for different versions of Android, and we maintain all of those because we need to support different versions of Android. And indeed, leaping ahead a little bit to probably what we'll talk about next time, one of the repositories that I maintain for the Octo project for Open Embedded is called MetaMono. And that provides Linux support for running .NET applications. Excuse me. So it's kind of like you can develop a sort of C sharp .NET Microsoft kind of application and actually run it on Linux, which, oddly enough, some people want to do. And I did a lot of work on that, so I ended up maintaining this. And what you can see with the way there's all sorts of things going on with this. And if you want to really get into Git and repositories and workflows and continuous integration, stuff like that, this is probably a reasonable place to go and start. This is sort of my level of where I've got to with my understanding of how these things work. And I have lots more to learn too. But in here, I've got my README, which is in Markdown. And one of the nice things I've done here is I have some automated builds and tests going on. And I automatically, when a particular build works, I've got a little icon that says, yep, that branch is okay. These are all different branches. And you can see that we've got this master, and then we've got all these different branches in here, loads of them. And the reason that we have different branches here is because the Yocto project for building embedded Linux has different releases. If you look at the Yocto release cycle, you can see that going back for ages and ages and ages and ages and ages, 2006, I guess, a fair old while, isn't it? I think I started working with Denzel, probably, maybe Edison, so around and about 2012, 2011. And we've gone all the way up to these newer releases. We've got Kirkstone, Scarf Gap, Styhead, Walnut Scar. They've started naming them after, I think, mountain ranges or something nowadays. And you can see there's different versions and there's different periods of support for them. Some are LTS, which is long-term support. And so support is still being maintained. Other ones have reached end of life. And then there's newer work and future work. And what we try to do with MetaMono is to support whatever the upstream from us Yocto project is currently supporting. And so we have a different branch for each of these releases because they're not interchangeable. One branch for Dunfeld release, say, is very unlikely to work with a more recent Scarf Gap because they make all sorts of changes. So that's another reason to have branches. And if, for example, I wanted to, a lot of people, so we're getting into a more complex project now, aren't we? Yeah. A lot of people maybe aren't going to be working on the bleeding edge of what some group is doing. They'll be using an older release. So I might even be using the Dunfell release. So if I want to start working with Dunfell and I want to get the right branch of this MetaMono repository for Dunfell, what I would do is I would go and get the URL, probably going to use the public URL for HTTPS here. And then I'm going to go out of that repository. I'm going to go into my projects and I'm going to git clone the URL. And if I just do that, it will clone whatever the default branch is, which is a setting. And that will generally, but not always, be main. And you should always check that. Here, it's telling me that the default is master because this is a bit older. We've talked about that. But I can choose to clone something else. And I want to work with Dunfell. So if I just leave it at that, it's going to clone master. But if I don't want that, I say, okay, I don't want that. I want to clone the Dunfell branch. And that's exactly what it'll do. So if I now got a new folder, MetaMono, if I look at the branch in MetaMono, it's Dunfell. If I look at the log of of this branch, Dunfell, tells me all the latest bits and pieces. And you see we've been merging things in and we've been doing all the kinds of things that we talked about. Now, one other thing to point out is, sometimes you want to be sort of playing around with a couple of different things. So I might be using that MetaMono Dunfell, but I might kind of be thinking, I also want to compare it with some of the newer stuff and see what's going on. So maybe I check out the master branch. Now, this isn't going to work because it says, look, you're trying to check out the master branch, and by default, that's going to go into the name of the repository as a folder locally, which is MetaMono, but you've already got one, and that's going to go horribly wrong. So I'm not going to do that for you. So what we can do is we can just give it a different name. So I'm going to do metamono.master, say, and then it will clone that into metamono.master. And I could sort of do stuff. I could be comparing files in different folders to see what the differences were. So those are just some sort of little tricks and tips, which are quite helpful to be able to do these things. Now, I'm going to have to go quite soon, but I do want to try and wrap up a little bit talking about what we were saying, which is how we do this merging stuff. Went blank there for a second. Do this merging stuff using some of the GitHub stuff. Now, so what I might do is we'll go back to our Git test. We're going to create another new branch. Let's check what branch we're on. We're on main. We're going to create a new branch, AJL dodgy branch. And I'm going to make some changes. This won't build. And I'm going to look at what's going on there. It's a change. Not a work, is it? But I don't care. I need to get off. So I'm going to add that and commit that anyway. I'm a bad developer. And awesome change you really need. And I'm going to push that up. Again, remember, we can set defaults if we don't want to set them every time. So that's now pushed it up. That's gone up to the GitHub repository. Being quite helpful, one of the things it's saying is that you can create a pull request for this branch if you want by clicking on this link. And that's really kind of what we're going to do, but I'm going to do it in a slightly more roundabout way, just to show you. So if we go back to our Git test repository, and rather helpfully, isn't it great? It pops up and it says, do you know what? There's been a push to this dodgy branch here. Do you want to compare and create a pull request? And I do. So what I'm going to do is I'm going to compare this branch, dodgy branch, with somewhere else. Now, it doesn't have to be the main branch. It could be anywhere. I don't always have to merge into the main branch. I can merge this branch to that branch to the other branch. You can get, Make this as complicated as you want. Whether you can keep track of it is another question. So typically, you'd probably have one or two main branches, maybe different version branches, and merge into them. You're like trying to keep on top of this stuff. I'm just going to merge our dodgy branch into the main branch, and I'm going to say it's an awesome change. Okay, we could add in descriptions and all sorts of stuff. And there's all sorts of GitHub things that you can do. You can require a minimum number of people to review changes. You can assign people to do reviewing. You can add labels and et cetera, et cetera. I'm going to assign me, although I don't have to. And I'm going to create what's called a pull request. So this is a GitHub thing as opposed to a Git thing. And it's about how we go about reviewing and merging new stuff. Now, clearly, if it's just me doing all of this stuff, it doesn't really matter. But if I was doing some work from somebody else's repository and I'd made a copy of their repository and was working with it, I might want to contribute my changes back to them. And we want to do that in a controlled way. We want to be able to make it as easy as possible to review what I've done and fix any problems that I've created. So what I'm going to do is I've created this pull request, and I've now got one pull request, awesome change you really need. I'm going to review this, and it says, one of the rules, we can add rules on who needs to do what before we're willing to merge this thing in. If you look at the meta mono layer, we could talk about this another time, that actually runs a set of automated builds and tests which must pass to be able to do merging. But, this is much more simple. So what I want to see is we can have a conversation about what's going on. And I see that this is the change that was made, and it's emphasizing to me, these are the new lines, and that's crap. That's terrible. So I'm not going to merge that stuff in. No way. So what I might do is I might go back and, I might say, this is crap. Well, no, I'm not going to say that because that's very rude. So you might want to think about improving this a little. And I can post that comment, and whoever created the pull request would see that. They would get notified. And, okay, I'll have a little look now and see what the problem is. Okay, so we go back and, there was a bit of a problem. Oops, wanted to get away early. Actually, what I meant to do was print this will build. I'm actually going to do a proper job here, and I'm going to check that it actually does build. And it didn't, because I got it wrong. Good job I checked. Still coding in Python, I think, here. And I'll do it again. That worked. Test it locally. Yay, that's great. That's working now. So you can see there's a change because I fixed my problem. I'm going to commit that change in. Fixed my typo. I'm going to push that up. And what's really nice here is that because I pushed the new commit onto the branch, which I created the pull request from, those changes have automatically come into my pull request. So my pull request has been updated. So I responded to me, it's all getting a bit crazy, isn't it? I responded to me, you might want to change this stuff. And then what should have happened is that we've got a new commit into this, which you can see, and it's telling me there's a new commit. It's saying there's a new change since you looked at this. Okay, fine. He's fixed the problem. Yes, I fixed my typo. You see, there's two commits now instead of one. Okay, well, let me see what I've done here. Have I sorted myself out? Okay, so I've taken out the crap bit and I've added in the right bit. Okay, I like this guy. That's good. So I can do some other stuff. I can review the changes and I can say, this looks great. I can make that comment, or I can approve, or I can request changes. I can do all of these things. I can actually see how to kind of get this in there. So do that. And now that I'm happy, and again, remembering that we could do all sorts of other kinds of tests in a more complicated project before we get to this point. And I do that in Metamono. Take a look at it. I'm happy with that now. So I'm going to merge the pull request in. There's a couple of different ways of doing things, squash and merge or rebase and merge, but I think we'll leave that to another time because we're very much out of time now. So I'm going to merge that pull request in. That's all good. And what we've done, successfully merged and closed from a JL dodgy branch, and I can delete that branch if I want. Let's get rid of the dodgy branch. We don't want a dodgy branch. So that's gone. And if we go back over to the code and we look at the commits into the main of branch, I've merged in the pull request from dodgy branch, and you can see what that change is. There you go. And note that the intermediate bit that wasn't right, that's not there. That's gone. We didn't want that. We got rid of that. It's only got the right bit at the end, which is what we want. So that's how that stuff works. And I think that is probably a good note upon which to finish this second session. Do either of you have any questions on any of that?
Yeah, I have one question.
Okay.
So if now I commit any, like I change any code and I commit, will I need to do pull request again?
Yes.
Okay.
Yes. If you the thing to do now would be to basically again, I'm trying to show you the ways of working here, but there's a lot of flexibility in how you can go about working. What I would tend to do, if we've closed down a particular branch, it's very confusing if we're trying to do any more on it. So I would create a different branch. I might do a JL dodgy branch 2 if I was going to do some more stuff like that, just to separate things out so that different people can actually keep track of what's going on. That makes sense.
Yep.
Anything else?
Yeah, so I just want to make sure, is a pull request just a way for someone else to review what you did in your branch?
Yeah, not just. Essentially, that's the purpose of it. It's you will tend to have one or more people who are in control of a repository, who may be maintaining a code base, maintaining the repository, and they view their job as maintaining the quality of what they're doing. And you, as somebody who wants to contribute to what they're maintaining, request them to take this stuff from you. And depending on the kind of person and what their expectations are, they'll receive that pull request, and from one end of the scale where they'll just ignore it to the other end of the scale where they'll review it and say, wow, fantastic, thanks very much. Or they might ask you to change a few things to fit in with coding conventions or the way that they write software, and you can have a dialogue and do all these things. And that can all be done just with the Git tools. And if you look at the sort of pre-GitHub ways of doing things, what would happen is somebody would create a patch set and email a patch set to a particular list, and those patches would then be reviewed by a maintainer on the list, and there would be an email conversation, or possibly through a different web portal. And that's still actually how a lot of the Yocto and Open Embedded work occurs. For me, I find this pull request workflow much, much, much easier to track what's going on, see who did what, look at the conversations, look at the changes, go back. All of this stuff, well, a lot of this stuff is about making sure that only good code gets into the code you're using, and therefore works and gets reviewed and gets tested. And also that inevitably, when there are some problems, we can go back through what's happened and figure out what went wrong and where it went wrong and how we fix it as quickly and easily as possible. Yeah, and that's mainly it. Yeah.
Thanks.
Pull requests also can relate to issues. So, if we've got some kind of problem, we might raise some issues to track what's going on. and then we might create pull requests against those issues. And again, that gives us an audit trail. So even sort of within our own internal team, we might say, right, we've got these 5 issues to deal with. And rather than sort of merging things in willy-nilly, we might do it through this pull request mechanism just to make it really clear that this is what we're doing here on this pull request to fix this issue, that we merge into this code at this point. You don't have to do that. You could just merge it all in by hand. But for me, anything that makes it easier to track what's going on is generally a good way of working. Good way of working. Okay.
Yeah, thanks.
Cool. I think I'm going to have to shoot off now, folks, because I've got to get into a meeting. Hope that was useful. It's taking longer than I thought. Clearly, there's at least one more discussion that we need to have to move on to diffing and patching and cherry picking before we get on to the really complicated stuff to do with bisecting and things like that, if I can remember how to do it. So we'll have to schedule that in sometime soon. Yeah.
Thank you, Alex.
Okay, I will catch up with you tomorrow then, Shreya, and hopefully yourself as well, Yari. Yep. See you later.